I've made a lot of additions to this guy. I've had to change it around. As you can see, I've added more legit water cooling because what I had before was just not going to cut it. Even if I increased the reservoir, put more fans on it, it just wasn't going to work. So this is a pretty legit cooling block. It's got a bunch of fins on the back, and it's got like 12 pipes running through it. Just using one of these little water pumps here. Those are really legit. I've also got this guy right here. One of those has been running for like years now, basically emptying out my, AC drip pan. Here's another one that's just slightly higher power. So if I wanted to try to move more water, I could, but that seems to work fine. And you can see I've got some big beefy fans on there. So you need to move this one, but this is to cool the caps. So basically same setup, but I've just, beefed that up. Added a supply over here just for the fans. I didn't want to get too complicated, but I basically just want to be able to adjust the speed on those only when they're needed because they're really loud. So I don't really have those running most of the time. So I've got supply just for those. 12 volts out here, still running the pump. A couple other fans. And then I've also added just an overcurrent board. So this is basically just, now with this addition, this is more or less Steve Ward's DRSSTC 1 driver. I'm using different gate drivers. I've got a PLL chip on there that I'm using the VCO for. But otherwise, that's how the overcurrent on here is working, right? So I'm just, before I was using this as feedback, but as it stands right now, I'm not using feedback. It's just sort of grounded out through a resistor. I'm just running the thing off the VCO. So what I did was I went back and just sort of cleaned this up to where I get a better duty cycle, and I'm just going to run it at the resonant frequency off the VCO, right? So no feedback otherwise, or no feedback except for the overcurrent, right? So basically, it's the same thing as the Tesla coil driver circuit, right? You just feed a voltage into the comparator, which comes off your CT, through whatever burn resistor you add on there, which gives you sort of a trimming range. And then once that goes high, the 555 pulls the turns a switch on, and it basically pulls the enables down. So that's just what I'm doing here. It's just pulling the enables down, shutting the gate drive off, and theoretically I should be able to set that to a reasonable level. That'll keep the tank current from going up, way too high. And then, I'll just have to limit the input current. So basically, that's how that's set up now. And I just decided to make like a power board for it. I should really clean all this up, but this is just sort of like a sloppily tossed together of a power board that I figured, hey, that'd be a good idea. So I can kind of use this for other things, but just have one plug for 120 VAC that'll give me my isolated control voltage. So this is just like a doorbell transformer, and a couple supplies for that. So I basically decided to just have one supply giving me 24 volts out for other controls, and then I'm coming out of that because mainly I wanted to protect this supply. The output of this is like 36 volts peak. I think this only goes up to like 32 or something. So basically, this right here is going to be my control voltage for the driver, which, since I'm using linear regulators, I don't really want to feed those a whole 24 volts just to drop down to, 18, 5, and 12, right? So trimming it down to about 20 is good enough, and it doesn't overheat the linear regulators. And like I say again, then I've got the regular 24 volts out here, and this is where I'll just have all my breakers and stuff. You can see I just added a contactor over here. The whole point of that is just so if I want to in the future use like a CT like I've got here to create a overcurrent circuit just for that, to open up like the contactor or something, just in case I don't want to completely rely on breakers and stuff, right? So that's pretty much all that is. So basically, I have my control voltage now, but then I need to cut the Tesla coil, or not the Tesla coil, but the induction heater control voltage on. So you can see that's just a little under 20 volts. That's all I'm feeding in here. And that'll more or less run all this as well. So if I want to cut the fans up, and if the water cooling just isn't quite cutting it, then again I can cut those up. And I've got those limited to a certain point, let's just say, because I need to add a fan to cool these converters there. So basically that's just how that would work. So if I wanted to add more controls, then I can you know, some digital out, have the contactor open and close for some kind of, you know, fault situation or whatever. So that's all that is. Power in, and then I'm going through the variac right there, and bigger heat sink, and kind of see how that goes. So I'm waiting on a better resonant capacitor, and then hopefully then I'll really be able to crank this up. But right now I'm basically just sort of testing out, just barely hugging over like the 10 amp regions, right? Alright, so now I've basically got the overcurrent circuit to where I'm just using this DC supply here, and I've set it to 3 volts. And that's what's across the burden resistor, and it's going to go into the comparator. And I'm basically just going to have this running. I'm just going to turn the voltage up just a little bit. So you can just see I've got about 10 volts, it's oscillating, pulling just a little bit. And then I can actually adjust the trimmer till it trips, just to test, and you can see the output stops, the circuit stops oscillating. So if I cut it back down, it turns back on, cut it up, cuts back off. So basically just like you know, running a DRSSTC, same circuit. So pretty nifty, right? So basically I'll just have to again tweak around these values, because this is it, just a random 3 volts, random burden. So as far as what I need to set this, you know, for actual overcurrent levels, I'll have to tweak it around. But in theory, you can see it's basically working. So that's cool. So here'd be kind of an example. I've got it set to where I've just barely backed it down, right? So I'm pulling about 6.5 amps. I'm not very high up in the power, 55 volts or so. So I'll just put the screwdriver in there. So basically when I remove the load, then the overcurrent should kick in, right? So pull it out, put it back in. You see when I pull it out, it doesn't actually shut it all the way off. So I might need to tweak that around a little bit.